Hello there, this is Joseph D here, and off a new video recorded 28th of March year 2022. Here today I'm using the Unimat 4mm with a custom motor, and I'm building another geared motor, and this is a 240 volt DC motor, permanent magnet motor. Now I've got a motor end cap which is going on to the end of it, which is this part here, and it's clamped in here, and I cast this part myself, and I'm in the middle of boring out the holes for the brushes to go. So what goes in there is these brush caps, you know, these fitting, they're pushed in. It's a tight interference fit with a bit of special super glue that keeps it in place, Loctite, so that keeps that in there. So I'm just in the process. I bought the hole ready, and I'm just boring this part here, which is, you know, the brush holder has a part which is slightly more wider than the rest of the thing, so there has to be a corresponding hole. So I'll just start this and show you what I'm doing. So I've been brought to a 10mm depth. Which is about there. So that's like that. So I just take this boring bar out now. It's a 6mm lathe tool, by the way, I've used in here because the boring bar for this was too big. So I've just taken a 6mm lathe tool, I've cut it down, and then using that, and I'm getting a good result with it. So now you can see a more clearer view of the picture. That's designed for this to go in, so I just try it, and it fits in nicely. That fits in nicely, but the hole that it goes into is slightly more narrower, which is to accommodate this, and that is where it's very important, because that's a very tight push-in fit. It's pushed in, you know, you put a bit of Loctite on this, and then this is just pushed in, and this part sits level with the casting, like you see on mobility scooter motors. This is the same design, I've copied it. I couldn't get them in a small size, so I've made one. So that's it. I'll take it out of the machine and show you the actual casting. So I undo that voice. I use these for mica, you know, pieces to stop so I don't mark my work. But here is the casting. So that side has been bored out, but it hasn't been, you know, enlarged yet. This side has been enlarged to take the brush holder. So you get a good look at that. I used a metal pattern, which I did. I'll see if I can find it, but I used the metal pattern. Just hold it there 1 second, I'll get it if I can find it. Here we go. This was my moulding pattern. I know, crazy as it might seem, but it worked. So once upon a time, this was inside here, like so. You see there, you see the places where the brushes are, you can see the corresponding crevices in there, and the same on the other side. Can you see that? And this is a two-part moulding pattern which I made from some scrap steel. It works very well. You have to heat it very hot first before you pour the metal in. Otherwise, if you don't heat this hot before you pour your molten metal in, it will bubble and it will give you all sorts of casting defects. There's one or two tiny defects, but nothing serious. But the rest of the casting is alright. I made offers and they came out perfect. This is just one I'm using for a job. So I wanted a geared motor which turns with a lot of torque. It's to drive a sawing machine which I'm building. Now this motor, there are plenty of geared motors out there like this, but for some reason the motors they give you are induction motors and they only spin at 1,300 and something RPM, which is very slow. So what I did was I took a motor from a cheap table saw from China. I made this end cap, by the way. This wasn't cast, it was machined from a piece of aluminium billet. So that's been made. I made that also from billet too. That's the adapter to go onto the gearbox. Like so, it goes that way. So there's the location thing that corresponds with this. So that stays like so. 4 holes are drilled accurately for 5mm bolts to pass through. This part, which is the flange, is going to be tapped and screwed. It's going to be screwed onto there. That holds the motor onto the gearbox. So that's that. And the motor screwed together with 2 long screws. That keeps this piece in place. Now you can see it now if you look at it. That's the original motor from the table saw is being cut up and being pushed into this thing. It was originally that shape. It was never round, and I've basically pushed it into this tubing to get a nice size that corresponds with these castings and neaten it up. So if I take this out of here now, just bear with me 1 second. This magnet's very strong, it doesn't want to let it out. You can get a good look at it now. There's a motor armature and there's the permanent magnets taken from the saw, as you can see. A few aluminium bits of steel shavings in there, I've got to get them out, but that's a finger and thumb job. But here we go, there's the new armature which I've taken from the table saw. I've cut the end off it and I've grafted the end from the induction motor. It's a oriental motor and that goes into there and drives this gearbox. Now this motor spins at 4,000 RPM, 4,500 RPM instead of 1,350. So this allows this to turn much faster than it would do it originally. So it can get me the right speed I need with the torque behind it to drive this saw. Because this saw, I'm going to put it on YouTube very soon. This is a saw which takes junior hacksaw blades, but it's spring loaded. So as this motor turns, it requires a lot of force to turn it up and down to make it move. Every motor I've tried which is like this with just an ordinary gearbox stalls after a while because it can't cope. But this gearbox is something like a 36:1 ratio. So it's got a lot of gearing inside to give it the torque it needs. But unfortunately, with so much gearing, it loses the speed. So in order to get the speed back again, I need a more faster motor. And this is what I'm putting in. So I'm installing this. So as you can see, that fits into there like so. And that's where you can see there the brush is the communicator. So that's where the brush holders will go onto and the brushes will touch. I've got a mark there which I've gonna drill for a wire to come through. That's the main supply voltage wire. So I hope you like this, guys. I have to leave this here now, but thanks very much for checking out this video. And this was my mill, which uses also a DC motor bought off eBay, and I made a nice job of that. It's got a tooth drive belt, so I don't get any more belt slip, because I love the Unimat 4 machines, but their belt system is very wimpy and they don't give you enough power regardless of motor. So I've got another motor, very strong one, and with a variable speed. I think there's something like 60 quid off eBay still. There's a fella selling them, and I've coupled it to a belt drive from a lawnmower, and it seems to work very well. If I start it, I'll show you. I usually keep it about there. That's about roughly a number 6. That's the perfect speed for my milling work. So that's it. Thanks for checking this video out. Have a great time and enjoy your projects, and look out for more of my interesting videos. Kind regards, Joseph D. Bye.